Greetings and welcome, friends. We've been talking lately about the law of sines, and specifically on our homework, page 324 last night, we were considering cases in which we have two possible outcomes. Whoa, let's see, where'd my mouse go? Here we go. Whew, all over the place. So, problem 19, I've got an angle, 58 degrees, so let me draw a picture of this. So 58, something like that. 58 degrees, that's angle A. And let's see, side B would be my adjacent, so that's 29. And then side A is 26, and that is going to be a situation where we actually have two possible cases. How do I know that? Well, technically I could use the height equals the adjacent times the sine of the angle. Because I can see that the opposite side of 6, yep, there we are, is shorter than the adjacent, all right? But now I just have to technically prove that it's longer than the height. So h is equal to 29 times sine of 58 degrees. And we've got 24.59. So because 26 is longer than that, there are two triangles formed. All right, that I'm trying to solve now. So I've got to consider both cases. Now our two triangles, one of them is going to be this larger and acute triangle, and then one of them is going to be this sliver obtuse triangle here. Okay, so to label some of my stuff, we'll work with the green one here first. Let's see. So this must have been angle B. This must have been angle C. And in case you're wondering about the labels for our other ones, if this is angle B, then the obtuse version of B will be B prime. The smaller version of angle C will be C prime. And this little side, the shorter version of side C, will be little c prime. Whereas the big version will be little c no prime. Little c no prime. So that's our situation. So the first thing I'm going to do is let's do some law of signage to figure out my green larger acute triangle. I always want to, when I see it's larger, I always want to say obtuse, but no, that's not what I mean. So let's see. The first thing I could find for my primary green triangle here looks like angle B, because it's paired up with the 29 that I have. I've got some A's there. That's how I know I can use some law of sines. Well, also that's the only technique that you know so far for solving non-right triangles. So I'm going to, since I'm looking for an angle, I'm going to say that sine of B over 29 is equal to, what do we got? Sine of 58 over 26. So to solve, I'll end up getting sine of B equals 29/26 times sine of 58 degrees, obviously. And how do I get B by itself, angle B, big B? Sine inverse, both sides. Sinverse. So angle B is going to be approximately, let's see, so second, sine inverse, 29 divided by 26 multiplied by sine 58, close parentheses, and I get angle B is 71.07 degrees is my approximation. So there's angle B. All right. So now I can find angle C, the big version of it, right? And angle C I could find by doing what? You got it, dude. So let's see, 180 minus the sum of those. So 180 minus parentheses, second answer, plus 58. Whoa, close parentheses, is 50.93 degrees. And now I could find little c, this version of it, because I just found angle C, right, being 50.93 degrees, right, something like that. So I can find little c, doing some sine law of sines. So little c over sine of 50.93 degrees, and I'll compare it to the a's again since that's what information was given to me. So it's been unaffected by my potential errors. So to solve for c, I'd just multiply both sides by sine of 50.93. Someone's phone was stolen, apparently. Very valid information. So let's see. Let's find little c is equal to 26 times sine of 50.93 divided, close parentheses, divided by sine 58, close parentheses. And I get little c is equal to 23.80. So that's all of my original green triangle's information. Let's see. So 23.80 is that information. But now I've got to figure out, what about my purple triangle? Because, I mean, if I could somehow claim probability in this situation, you could argue there's a 50-50 chance of either the purple or the green triangle being the right one, if that makes any sense. But I don't know if you'd even apply probability here. So the first thing I want to point out about this purple triangle, well, is if this is 71 degrees, right, 71.07, and this is 26, well, this side is also 26, right? These are congruent because, well, that was part of my given information, and that it was this swinging 26 side that was my hinge, like on a door, right? Spinning on angle C here, that landed in these two spots. So 26 and 26, this triangle that is technically, it's neither of the solutions that I'm looking for, all right, but it's still related to the triangle that it's going to help us solve, is that this angle and this angle are going to be congruent because it's an isosceles triangle by the base angles theorem. So if this angle is also 71 and I'm now looking for B prime, how could I find B prime?
Can't you add angle C and B and subtract angle B?
Well, B prime and B angles, or at least this, congruent angle to angle B, are going to be a linear pair. Linear pairs by the linear pair postulate, LPP, supplementary, right? Linear pairs add to 180, stuff like that. So I could find, now let's see, there's angle B. So I could find B prime by doing 180 minus, well, angle B, I suppose. So B prime is going to be approximately 180 minus 71.07 is 108.93. And this is going to be the thing that throws me into the whole realm of a different triangle to solve for. So now I've got B prime. I could now find C prime. All right, big C prime, which, just to bring back to our sketch, which if you'd like to draw this as two sketches, that can be a really good idea. I like that idea too. C prime is going to be the smaller of the two C's because it's much tinier now, and also because angle B just got a lot bigger in B prime. So that 180 degrees can only be divided up by those three angles. So if one's getting bigger, something else is getting smaller. So C prime I could do by is going to equal 180 minus A plus B prime, right? So C prime is equal to 180 minus parentheses, second answer, plus 58, I believe, right? So I'm going to get 13.07 degrees, so very tiny sliver of an angle. And now that I have C prime, I can find little c prime, doing some sine inverse. So C prime over sine of 13.07, we might as well compare that to the A's again, so side A and sine of angle A. So to solve for little c prime, I could multiply both sides by sine of 13.07. And little c prime is equal to 26 times sine of 13.07, close parentheses, divided by sine of 58, close parentheses. And I get 6.95 3, roughly. So those are all of the possible situations for my triangle. So instead of just trying to find 3 pieces of information, I found 3 pieces twice, if you want to think about it that way. So I had to solve for the green triangle and the purple triangle. And then the big stepping stone that allows me to get the second triangle is kind of the base angles theorem mixed with the linear pair postulate, allowing me to find that angle B prime right there. So that's the idea for that problem. Let's try the same thing for one more problem. We'll see how much time. It took 10 minutes. We'll do this problem. We're good. We're good. So we'll see what happens. Let's see. So 47 degrees, something like that. And I always try to draw this in roughly the same setup. So here's my angle C. So A is going to be my adjacent, right? We did 27, right? Did we? That was part of last night's quest?
Mm-hmm.
Okay. I'm thinking this might not end up being a 2-triangle situation, is it?
No, that's what I realized too, because they
Aha.
said it's longer than your D.
Yeah, because C16 is longer than this one, so I can't possibly have it fit here because it's too long. So the only way to have it fit is actually, it's a 1 solution situation. It's going to look like that. So let's see. So this is going to be my angle A. This is going to be my angle B. So it's not a 2-triangle situation. The way we would have figured that out is doing H is equal to 10 times sine of 47 degrees. Well, actually, no, I didn't even need to do that. Because I could just say 16 is bigger than 10, right? Basically, my opposite is longer than the adjacent. So it's only 1 triangle. And that's why you would have ended up with a negative when you tried doing your B or A prime, right? Because this one, actually, one of these is obtuse, I think. Anyways, we'll figure it out. But yeah, it would end up not working out. So let's solve this anyways using law of sines. The next thing I could find is angle A because I have a side A and I've been given a pair of C and side C, right? So I'm looking for an angle, so I'm going to say sine of A divided by 10 is equal to sine of 47 degrees divided by 16. Multiply both sides by 10. And here we go, here we go, here we go. Multiply. And I'll get sine of A is equal to 10/16 times the sine of 47 degrees. And how do I get A by itself? Sine inverse. The only way to get rid of a sine. Sine inverse. So I'm going to get angle A is approximately the second sine inverse of 10/16 multiplied by the sine of 47, double close parentheses, and I get 27.120 actually if I round up degrees. And now I could find angle B, which I think this might be the obtuse one. So 180 minus A and C. Right, so angle B is going to equal 180 minus, parentheses, second answer, plus, what was it, 47, close parentheses. And here's my obtuse angle, 105.80 degrees. Good stuff, good stuff. And now that I know angle B, right, I could then find side B, because I can use this pair in trying to determine my law of signage. So I'll do little b over the sine of 105.8 degrees or 80 degrees equals, and I'll compare that to the C's 16 divided by the sine of 47. So to solve, I'll multiply both sides by the sine 105. Right. And little b is equal to 16 times sine of second answer, close parentheses, divided by sine of 47, close parentheses. And I get 21.05. And yeah, so this one only had 1 triangle solution. So So yeah, right there is what we had. Bam. So not too bad. The idea is if you have two triangles, you just have to relate it to the base angles theorem and linear pair postulate. You can find the other one, not too shabby. So thanks for watching, friends. Have a great day. Bye-bye.